All right, so the next thing that we're going to be doing is taking a look at some of the main different types of reactions that we're going to encounter. So types of chemical reactions, right? We'll abbreviate reactions as RXN. And we'll take a look at some general examples and then also some specific ones. So the first one we'll take a look at are reactions known as combination, or sometimes they're called synthesis reactions. And these are characterized by having multiple reactants that combine to form one type of product. Okay, and that's going to be the key thing here. Multiple stuff on the left side, making one type of thing on the right side. So generally, we can say if I have a substance A and a substance B reacting, these can combine to make a new substance AB, right? So this is sort of our general. And then specifically, in a specific example, would be something like the one we did initially. So we saw hydrogen reacting with oxygen to produce H2O, right? And we balanced our equation. So we had 2 and then 2, right? This would be an example of a combination or a synthesis, multiple, more than one reactant making just one type of product, right? So that's combination or synthesis. The exact opposite of this is known as a decomposition reaction. And here what we have are a single type or one type of reactant decomposing or breaking down to make multiple products. Okay, and we can maybe take the example above. Well, generally we can say if I have a substance AB, okay, some sort of a compound that can break down into A and B, two different things at the end, right? So specifically then, we can say water under the right conditions. We can decompose that to give us back the hydrogen gas when we get the oxygen gas, and then we need to balance our equation as well. All right, so just you can think of decomposition as the opposite of a combination. Let's take a look at the third one. And the third one is called a single replacement, sometimes referred to as a substitution reaction. And in a substitution or single replacement reaction, what we have usually occurring is an element replaces another element from a compound. Okay, so generally we can say if I have an element A reacting with a compound BC, right, what can happen here is A can come in, take the place or replaces B. So B then is kicked out. So now we form a new element, B, and then we make a new combination now between A and C. Okay, so one thing replaces or substitutes another to make our new products at the end. Typically, what we're going to see in these examples are a metal, or is a metal replacing another metal from a compound. So for example, if I have something like, let's just say like sodium reacting with, let's do iron chloride, so FeCl2. Okay, what can happen here is the sodium can come in, kick out the iron, so now we end up with iron Fe, And then the sodium combines with the chlorine to make sodium chloride, which we know how to come up with the formula for that. It's NaCl. And then we just need to balance our equation, right? So we'd have a 2 there, and then a 2 in front of the Na. That's a single replacement reaction or substitution. The fourth type is known as a double replacement, sometimes called a metathesis reaction. Okay, and here we have usually two elements swapping places. In their compounds. And usually what we're going to see are these elements are the metals, usually metal ions, swap places. There are other examples that you might come across, but this is the most common example that we're going to encounter. So for generally, we can say if I have a compound AB, let's say an ionic compound AB, reacting with another ionic compound CD, okay, the A, let me highlight these here. So this is AB, and then we have CD, and we'll do that in green. Okay, the A can come in, take the place of C, and then the C can take the place of A, right? So you have two things that are swapping places with each other. So I end up making two new combinations now. So A takes the place of C to make AD, and then C takes the place of A to make CB. So in terms of the color here, right, the B is still the yellow, the A is yellow, and then the D would be green, and then the C would be green as well, right? So we end up making two new compounds when these, in this case, the A and the C swap places. So as a specific example of this, let's say we had something like sodium chloride reacting with magnesium bromide, let's say MgBr2. Okay, so again, very similar here. The metal ions are going to swap places. So sodium and the magnesium are going to change places with each other. So now the Mg goes where the Na was to make MgCl2, magnesium chloride, and the Na goes where the Mg was to make NaBr. And then we need to balance our equation. So we need a 2 in front of the NaCl, we need a 2 in front of the NaBr. Right, so that's a double replacement or a metathesis. Usually metal ions swap places with each other. The fifth one we're going to take a look at is one we've seen previously, and these are known as combustion reactions. Okay, and in a combustion reaction, typically what we have are hydrocarbons, which mainly are carbon-containing compounds. Reacting with oxygen, O2, to produce carbon dioxide and water vapor. We saw 2 or 3 examples of this before. So for example, I think we'd used propane, C3H8, reacting with oxygen to produce carbon dioxide and H2O. Okay, then you need to balance that. That's an unbalanced equation. Okay, the defining feature of this usually in a combustion, right, we end up with the same types of products. You have your carbon-containing compound reacting with oxygen. So a couple things to note about combustion reactions is that these are the products we're going to get for complete combustion. And what that means is that we have the necessary amount of oxygen required to completely burn that fuel. So we say more than enough oxygen available. O2. In some cases, you don't have enough oxygen. Maybe you have a fire or something, you're burning something, and the oxygen supply is limited. It's restricted in some way, shape, or form. And if that happens, and we have incomplete combustion, so if there is not enough O2 available, then instead of having complete combustion, we're going to have incomplete combustion. And if the fuel isn't being burned completely, then there's another product that we're going to make, which is carbon monoxide. So carbon monoxide can be generated, which is CO. Okay, and carbon monoxide is very, very poisonous. Okay, small amounts can actually kill. So we really want to not have incomplete combustion, especially in enclosed spaces, because the CO can build up very, very easily. So those are the 5 major types of reactions that we're going to encounter. Within these, there are some subcategories, and we'll talk a little bit about other ones down the road. I do want to mention 2 more types that can accompany some of the reactions we mentioned previously, and those are reactions that involve energy changes, and specifically now energy changes that accompany these reactions. So energy change, and we're going to limit our focus here to these energy changes being mostly heat changes, often accompany chemical reactions. So there are 2 types of situations that we're going to encounter. We have situations where heat energy or heat is produced or released. In a reaction, and we refer to that also as an exothermic. Right, so heat energy is given off when that reaction proceeds. So if you go back up to this combustion reaction, you probably know from experience that when you burn a fuel, whether it's propane, butane, whatever, ethane, the gas stove at home, the other thing that we get, right, is we get a bunch of energy. Right, heat energy, light energy, for example. So then this would also be classified, not just is it a combustion, this is also exothermic. Okay, and usually you'll notice that here I've put the word energy being produced, so it's on the right side as a product. Okay, so that's one thing that we can also notice. Exothermic reaction, we can think of heat is a product. And in some cases, you might see the word heat or energy, or you might actually see a value for that amount of energy. So, or let's say, for example, 350 kilojoules, right? So you'll see a unit here of energy that tells you, well, guess what? Energy is on the right side. It's a product. That means that it is an exothermic reaction. So that's one example. The second one, as you can maybe guess, is where heat is absorbed or required in a reaction. Okay, and in this case, it's not exothermic. This is referred to as an endothermic reaction. Okay, and in this, if heat is a product in an exothermic, well, then in an endothermic, which is the opposite, heat would be a reactant. Okay, so you'll see the word heat on the left side. You'll see a unit of energy on the left side. Either way, that's how we can differentiate between one and the other, right? So often, not always, but often there are heat changes, energy changes that accompany chemical reactions. And you can see it in any of the previous five that we talked about. These can be exo, it can be endothermic, depending on what specific reaction it is that we're studying.